Hi, future doctors. Welcome to the next class. In this class, we will discuss strain energy and energy density. We will discuss. So, what is the strain energy in these properties of solids? Means if you are taking any object, if you are applying deforming force, it is going to be under strain whenever you are applying stress. So, some amount of energy will be stored whenever object in the form of strain. So, this is called strain energy. Energy possessed by object whenever it is at strain position or whenever its size and shape is changing, then it is going to acquire some amount of energy. So, for this, how we are going to apply formula means every energy we will do from work done. So, work done is nothing but force into displacement. So, this force will take average force here without taking that integration derivation 0 plus F by 2. Displacement is nothing but elongation. So, they will write energy is nothing but of force into elongation. This is the energy. They will give graph for you people force and elongation. So, whenever they give graph, what is the energy they will ask? Simply area under force elongation graph gives energy. Now, what is energy density? So, normally density means we will say mass per unit volume, mass per unit length, mass per unit area. Same like that, energy within this volume, we are calling it as energy density of force into elongation by volume. We will write of force into elongation by this volume, we can write it as area into length. So, F by A we will call stress, E by L elongation, change in dimension by original dimension. Therefore, energy density is equal to half stress into strain, they will write. So, U by V is called energy density, half stress into strain they will call. So, what is the dimension formula for energy density? Already we got so many dimension formulas. All dimension formulas are similar to pressure. So, modulus of elasticity, Young's modulus, bulk modulus, shear modulus, isn't it? All these are having same dimension formula, that is equal to stress or pressure F by A, m L power minus 1 T power minus 2. So, now energy density is also having same dimension formula. Strain, no dimension formula. Stress, so it is same. Therefore, energy density also U by V is also having same dimensional formula. Energy possessed within this volume, we are calling it as energy density. Again, this one they will represent in Young's modulus definition. Young's modulus equal to longitudinal stress by longitudinal strain. If you want to eliminate stress, stress is nothing but y into strain. If you want to eliminate strain from this, strain is nothing but stress by Young's modulus. So, strain, if you want to eliminate, substitute here of stress into, in place of strain we can write stress by y. Therefore, half stress square by Young's modulus. This is energy density formula. So, if you want to eliminate stress, in place of stress you can write this. Then from this formula, U by V is equal to half y into strain into strain. Therefore, half y strain square. So, whenever strain is coming, y is in numerator. Whenever stress is coming, y is in denominator. So, all these formulas will be coming under energy stored per unit volume, otherwise strain energy. Energy only they are asking, then half into Fe. Sometimes they will replace this volume here. We have to take care how they are asking, how they are giving in options. Then definitely you can do this strain energy. Next, on this bulk modulus, how they will ask problems, we will see. So, bulk modulus equation we gave F by A by delta V by V with negative sign. So, B is equal to, this one they will write P delta V by V with negative sign. Volume, this is fractional change in volume. This delta V by V they will give, that is nothing but 2%, 3% it is going to be changing. So what is the bulk modulus for particular pressure? Newton per meter square. They are going to ask at the time. So bulk modulus can be replaced. So 10 divided by fractional change in volume 2%. So delta V by V. So delta V by V into 100 is going to be 2%. Then what is delta V by V? That is going to be 2 by 100. So they will write 2 by 100. So if you replace this, so 1000 by 2. So 500 Newton per meter square. Like this, they may ask, and bulk modulus, reciprocal of bulk modulus, we will say compressibility. 1 by d. After finding bulk modulus, you can find compressibility also. And this pressure, they will replace with rho gh. This one you will be getting in fluid mechanics. There we are going to discuss. P is equal to rho gh. On that also they are going to ask the problem. Sometimes they will give bulk modulus, they will ask pressure. So however they are asking, so you have to use this equation easily, you can solve the problem.